So we just talked about whole numbers, so integers, shorts, and byte. But in reality, we also have a different category of numbers, right? These are called floating point types. So floating points type, the idea is that we can represent decimal numbers, for instance, or fractions in real world. For those, we have float type, which is decimal numbers. So this represents all the decimal numbers you can imagine. And this holds 32 bits. And we have doubles that hold 64 bits. So all of these are floating point types. Now, there's a lot that's been written technically about these two types, mainly in computer science arena. There's books, there are studies, there are papers that have been written by computer scientists to really distinguish these two. But in a nutshell, the main point that you need to take, or we need to think about when we talk about floating point types, is all comes down to precision, because we want to be precise in the representation of certain numbers. Okay, so if you want a precise number to be represented, you would want to use double. Okay, because double will be able to hold more precision, because number one, it holds 64 bits, so we have more space for our decimals. All right, so let's go and take a look in code. How would we create these types? So imagine we want to represent a decimal number. Well, the first one we would think of is the number pi. So we're going to say val pi, and we're going to set that equal to something. In this case, it's going to be equal to 3.14. So this dot is what will represent a decimal number. In this case, this is going to be a double. It is a double because every number that we don't specify with F or D at the end, it will automatically be initialized as a double, because the compiler will always infer that this is indeed a double, because it will say, well, if you're creating a decimal number, that means you want the most precision, and double offers that. That is default. But the moment we say F like this, then this is going to be represented internally as a float. Now, in some languages, you could put just an F as such, or you could just go and actually add the uppercase F. But in Kotlin, you would just go F like that, the lowercase f. So now it's no longer a double, it is indeed a float. And let's see if we can print this and say pi. Let's run this and see what's going to happen as a float. Okay, it says 3.4. If I remove that, because we need more precision, let's see what's going to happen. As you can see, the number is still the same, but internally there are differences. Okay, so let's do this. I'm going to change this number. In fact, let's go ahead and add a few more decimal digits here. So 3, something like this. Okay, just gibberish. Let's run this. Okay, there we go. So nothing really new here. Everything is the same. However, let me change this number real quick. In fact, let's just say val and call this E. Okay, and I'm going to say 2.7182818 something like this. Let's run this. This, of course, it will be inferred as double, and you can see everything is good. Now, what will happen if I do the same thing? So val e float, and it's going to be equal to this whole number, and then I put f to say float. By the way, in Kotlin, you could either put lowercase f or uppercase f. Either way works. Let's see what is going to happen here. So I'm going to say print ln, because I want to use to print a new line, and print ln. Let's see, like this. Do the same. Now e float, like this. Let's see what's going to happen. Now you see the difference here. So the first one here, that's our e, right? Whole double number. It was very precise. It continued to show exactly all of our decimal digits as is there. However, when we change the same number to a float, because we appended the f, things change a little bit. You notice that we lost at least 3 decimals there, and what happened is some rounding ended up happening, because now this value here contains more than 6 or 7 decimal digits, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So more than 6 or 7. When we change to float, it's going to round itself up to at least 6 to 7 decimal digits. Okay, so that is the difference between, as we see, double and float. Float, it's not that precise, it rounds itself up, but for double, it will always be precise, meaning it's not going to round itself up as it does with float. You can imagine if you're putting together an application that will need precise results, precise numbers, definitely will go with doubles as opposed to with floats, for the reasons that we've just demonstrated here. All right. Very good. So I hope this is making some sense. And again, just don't stress too much about it if it's not making a lot of sense, because all I want you to understand is that you want precision, for these types, floating points type. If you want precision, absolutely go with doubles. If not really, then floats, that's totally fine. Okay, very good. I'll see you next.